So what we're going to look into here is what we call the Finch graph, and that is how we describe architecture as a graph. And a little backstory to this. So when we started Finch here, we felt really passionate about that, always putting the user in total control, going away from the black box and kind of enable our users to steer everything that's being generated. But we didn't stop at that. Besides being able to steer what's being generated, we also realized that it's very important to understand what has been generated and a way to control that in a way. So with that in mind, we started to think about a language that could describe the intricate relationship that the building consists of, all these hundreds of spaces that makes up a building. So we tried to find a language that both the computer and the architect could understand very well and communicate around. And what I'm going to show you now is our language, how it looks visually, basically. So if we start with a story like this one, we mapped all of the spaces in the entire building as a node per space that is packed with information about that particular space. And then we analyze and map how does all of these nodes come together? What is the relationship to each other? And as you can see, the graph grows here. It turns into the Finch graph. And that is a complete description of all of the spaces in the building and how they relate to each other. So what I'm going to show you here in a demo is how you work with the Finch graph and how you can steer what's being generated and how you can control what has been generated after that. But a couple of more words about the graph. Besides the relationship between different nodes, there's a number of things that we can get out of it. For example, egress distances. How far is it from one space to another space? What kind of relationships do we have in the building? Or even, is this room accessible or not? And this logic is what makes sure that we generate architecture, proper architecture that is put together as we know it. So you never end up in a situation where you go from the elevator into toilet. That is just not how we create architecture. But enough slides, and let's have a look at the actual product here. So just as Amelia showed here, I have my project here in Finch. We have our programs nicely structured. We have our spaces and all the data we need. As you can see, I have a story without anything generated here. And this is what we're going to do here in the demo. We're going to fill this story with the help of our graph rule. So I'm going to go into it, and I'm going to introduce you to a new tab up here called Graph Rules. So this is how it looks now. An empty story besides the circulation. You can see each apartment has a node because it just is one big space at the moment. And before I start generating things, I'm going to set up some really, really simple rules to guide the algorithm to present us with relevant results. Okay, so here I'm going to add a first graph rule. And I'm just going to say that my bedroom needs to be more than 10 square meters. It's a very simple rule. It makes sure that all the generated results that's getting presented has bedrooms that is larger than 10 square meters. And you can set whatever number you want, whatever space, and combine it, but we're starting simple like this. Then I'm going to click on a unit here and fire up the generation. And what the algorithm does now is that it analyzes where do we have the exterior of the building, where are the circulation, so we make sure that when we present the result, the entrance door to the unit should, of course, connect to the circulation and so on. If we just jump back to this one. So this is the classic interface as you all know it. We have our different plans presented here. I have the one from my organization, and I have some Finch generated results that keeps popping in here. And we have some nice colors to easily help us understand the plans. If I click one here, I can see that my bedrooms are green and so on. And then I can go down here and have a look at the Finch generated result and get some inspiration. And the new thing that we have now is that you can also click the Graph Rules tab. And in real time, as the generation go, all of the hundreds of plans that keep popping in here has been analyzed with the Finch graph. And if there are any problem, if we scroll down a little bit, you can see if we can find some problematic. Here we can see a result where we have an area that is actually smaller than the 10 square meters I was asking for. And one might ask, why do you show this one? Well, we took the decision, either you can filter out, which you actually can here in the filter, just show me the fully compliant. But sometimes you might have many rules that works on top of each other, and you might want to see the result as an inspiration and then go in and continue working with it. Okay, so I'm going to select one of the plans here that is fully compliant. I like this one, it's my project, and I'm going to assign it to the unit. Okay, so that's the first step. Let's fire it up again, or maybe we can add a couple of more rules here. So I'm going to add, I want my bathrooms, they should be larger than 2 square meters as well. And then we fire up this unit as well. And as you can see, my own plans are showing some problems here. That's probably because I designed this project in Sweden, where the bedrooms only need to be 7 square meters, but now I've set it to 10. So then I go down instead and see what Finch is generating for me. Okay, I'm just going to take the first one. I think this one looks great. I'm going to assign it to the unit. Oh, here can I see? I get a little warning that I have an angle that is not 90 degrees. I'm just going to fix it like this. There we go. And this particular unit is repeated out the building. I can see if I go into my unique units here, I have 4 of them actually. So I'm just going to copy it, select all of 4 of them and paste it. And then the unit is pasted into all of the other units here. And the graph rule does not only works on the things that you generate. I mean, if you have something in your plan bank as well, you can simply just right click, say, find adaptive plan. I know I have someone lying around here that I think will fit nicely. Yes, I'm assigning that one. And the graph rule works at these ones as well. So I get, this is of course a design I've used in another project. And here I also get a warning that I have some kind of problems. And I can go in and fix this either manually or generate something. So if I do it like this, it's more than 10 square meters. I have a small toilet here as well. Okay, and the way to fix this, now in my graph rules here, I said that all my bathrooms needed to be larger than 2 square meters. And the bathrooms here, I selected the space classes. That is kind of a collection, so the space class bathroom can contain a lot of other types of space types. But I can also go down and say that my specific space type that I have in this project, the bath should be larger. So that basically excludes the toilet from it, and I can set a separate rule for toilet and still keep my 2 square meter for the bathroom rule. Okay, let's fill the last one as well here. Let's generate the unit plan here. It's always satisfying to see how you work your way through a full story in just a couple of minutes here in a live demo to have some nice material that you know that you can work with. I'm going to click that one. That looks very nice. I'm going to copy it, and I know I have some that looks similar. Paste that one, and then let's go for the last one as well. And while we're looking at this, I think this is a good example. I'm going to choose one of my own plans that Finch indicate does not work very well. Of course, I could go down and select one of Finch's that works, but I'm going to show you one thing here. So this is a plan I had in another project that is populated with my own furniture that I choose for this project. I'm going to select this one. And here we can see the second kind of warning that the graph rules tell me about. I have some furniture within this that has what we call an accessibility bound that exists in most countries in the world. That indicates the area around, for example, a bed that need to be free. So if I have some collisions here, Finch also tells me about that. We have a collision detection. We have 2 of them here. And I can either, of course, make my room bigger here or I can also actually just delete the bed and add a single bed since this is a small apartment. I'm going to add this one. There you go. The algorithm is happy, it doesn't show anything. Let's see, we need to move the sofa a little bit as well. There you go. And I'm going to copy the last one in here. There you go. And if I have a look at the project, my space types looks great. So here, live, in a couple of minutes, I filled an entire story with generator plan, and I'm sure they're up to the standards that I want since I've created the graph rules myself. Right now, we support the area rules, the object collisions, but more and more rules will be added here over time. And one last thing, if we were to, let's create a problem here in this one. I'm just going to move the bed here so we get a little warning. When I then go out in 3D, you can see that I also get a nice indication that here is something wrong in this apartment, and it's very easy to just go into that particular story, find the unit with the problem, and go in and fix it. And when it's fixed, it turns white here in the 3D preview. So it's a great way of steering the algorithm, so you're in total control of what you're generating, and also check what has been generated, what has been edited, and so on. So that's it for the new Graph Rule Studio. Very happy to have it up and running. It's up and running for the enterprise customers right now. And as I said, more and more things are going to be added to this studio.